So now we progress to finding the ratio of two area. So this is going to be a brand new formula. This brand new formula is based on the assumption that the two triangles are similar. Okay, so this is the part where we call the area ratio. And this is the part where we call the length ratio. So if you look at the formula, the area ratio is a square of the length ratio. So that is the formula. So the formula is interchangeable. So if the formula is going to be like this, that means, right, I can find length ratio if I'm going to take a square root. So that's like manipulation of the formula. Okay, so let's come to an example to see how is it being done. Okay, so same thing here, we are going to prove for similar triangle first. So in this case, I think the proving is very similar to what we have done in one of the previous example. So this is the one where there's a common angle. You got a common angle and you got a given angle. Okay, so B is a common angle. And then you also have a given angle. So when it is given, you state the reason. So by AA, this triangle are similar. So part B is like what you have done just now. You got to be writing out the ratio, writing out that 3 ratio. So writing out the 3 ratios, insert the values that are given to you, and then eventually you go and find your AD. So you can give it a try to see whether you can get the answer or not. Okay, it's the same idea, the Sec 2 idea. Write out the ratio, put in the numbers, and see whether you can find the one that they wanted. So the critical part here is to get the ratio. So here I got 3 length ratio. So I got 3 length ratio. Okay, so let's explore it. Okay, so I'm going to explore this part. Triangle EBD. So it's the smaller one on top. So you can look at it. You can use this ratio, area ratio. So you take one of the length and square. Or you can take this ratio and you square. Take any of the length. I mean length ratio. And you square. So that is the meaning of the formula. You take any of the length ratio and you try to square. So which one am I going to be using? I think I will be using this one because this is a 5. And then BC is a 12. So I'm going to apply that ratio. So the ratios will be this over this, which ends up to be 5 over 12 with a square. So that's how I end up to be 25 and 144. So what's your interpretation of the 25 and 144? You interpret that as the area. So this 25 is EBD. 25 is the red color one. So this one is red color. So it's something like 25 units. Then the ABC is the blue one. So ABC is the blue one. The whole thing is 144. So everything here is 144. And that will help you to calculate the next part. The next part, this is a 25 units. And this bottom part, sorry, this is not a triangle, is ACED. So look for ACED. It's actually this black color. So this black color should be the blue one, subtracting the red one. So we use the length ratio to square it so that we can find the area ratio. That is in the case of similar triangle. So from proving similar triangle, you calculate length, you also calculate the area ratio. So you can only use this formula if the two triangles are similar. If the two triangles are not similar, this formula is not applicable. Okay, so this is just one of the first few examples on the area ratio.